So when we simplify the square root of negative numbers, so I'm going to zoom in here. So like if I have the square root of negative a, remember we said the square root of a -1 is I. So when I rewrite that as the square root of a times I, this is called the principal square root. And that just means it's the simplified negative square root. So that's like in the last set of examples that we did, if you just scroll up, we did the square root of -50, and we said that was 5i root 2. So this would be the principal square root, the simplified square root with an imaginary number. And that's all that is. So if we go down to more examples, this is example 5 from your text, and it's just to simplify, right, the complex number. When it says in standard form, basically what that means is simplify. Don't leave the square root of negative numbers. Don't leave an I squared in your answer. So just a reminder, the square root of -1 is I, and if you have an I squared, that's equal to -1. So that's what we'll use to simplify. So for letter A here, I'm going to go ahead and simplify each of these and then see if we can subtract them. So the square root of -48. So the negative, I'm going to pull that out as -1, and then 48 is 16 as a perfect square times 3. So this would be I, this would be 4, the square root of 16, and then 3 is going to stay underneath. So this would be 4I, and then root 3. And then I'm going to write my subtraction sign, and then let's go over to the square root of -27. So the negative I'm going to write as -1. 27 is the perfect square 9 times 3. So then if we simplify that, remember the square root of -1 can pull out as I, square root of 9 is 3. This 3 is going to stay under. So this side would look like, remember I like to write the number first, so I'm going to write the square root of 9, which is 3, and then square root of -1 is I, and then that root 3 stays. And now, as long as these have the same square root, so these are both root 3, as long as those are like roots or like radicals, we'll write that off to the side, they're kind of like terms. So as long as the square root number, I'm just going to write it like that, is the same, you can add or subtract. Okay, so it's kind of like having like terms. Root 3 and root 3 are like terms, so I can combine 4i minus 3i as 1i, so my final answer would just be I root 3 if I subtracted those two. So simplify first and then see if you can add or subtract. If this was a 3 and this was a 5, my answer would just stay at that step. I just wouldn't be able to combine them together. So for example, if it were 4i root 3 minus 3i root 5, that would stay right there because those are not like terms. So there's an example of adding or subtracting, in this case subtracting, but adding works the same way. And then let's go ahead, let's look at letter B. Letter B, we're multiplying. There's nothing in between, so we could put parentheses there, but we don't have to. So when you multiply radicals, you can actually go ahead and just multiply the numbers that are underneath. So I can go ahead, this is the same thing as a square root of -3 times -12. You don't need like terms in order to multiply. So -3 times -12 is positive 36, and the square root of 36 is just 6. So when you're multiplying, the negative times a negative simplifies to a positive, so I no longer have an imaginary number. My answer is just 6. All right, letter D is 5 plus root -8. So we have the square root of a negative. We do not want to leave that. So I'm going to write this as -1 times. And then 8 does break apart into the perfect square 4 times 2. So this is then, our perfect squares are the -1, the square root is I, 4, the square root is 2, that 2 is going to stay underneath. So this would be, between these two would be 2I root 2. And then I'm just going to copy down the 5 plus in front. And in this case, I cannot combine any further. They're not like terms. The 5 is a real number. The 2I root 2 is an imaginary number. So in this case, all we had to do was simplify the square root of the negative number, and we're done. All right, letter E, we have an I squared. So we know that I squared is -1. So this is 4 times -1 minus 2. Now, anything larger than 2, so any exponent, let's make a note here, larger than 2, actually, let's say larger than 1, needs to be simplified. Because if it's 2, it simplifies down to -1. So if you have any exponent for your imaginary number that's larger than 1, it needs to be simplified. And because we know the value of I squared, we can break I to the third into I squared times I, right? There's 3 of them there. So then I know I squared is -1. So this is 4 times -1, -4, minus 2 times -1, and then you have this extra I. So I can go ahead and multiply -2 times -1 to get -4 plus 2I. And as long as I essentially doesn't have an exponent, nothing larger than an exponent of 1, that's where we're good to go. So if you have any exponents larger than 1, like we have the 3 here, break it apart into anything that has an I squared with it, because that's what we are familiar with. That's what we know how to simplify. All right, and one more, we're going to go ahead and do some distributing with our square roots here. So let's see what we get. We are multiplying, and we do have complex conjugates here, right? We have root 3 plus root 15I and root 3 minus root 15I. So these are complex conjugates. Let's see what we get. Square root of 3 times the square root of 3. Now I'm going to write this out in piece by piece steps. Square root of 3 times the square root of 3 is 3, but that's because the square root of 3 times the square root of 3 is the square root of 9. And then the square root of 3 times negative root 15I is negative root, so I can multiply the 3 times 15, which is 45, and then that has the I with it. Remember, if you zoom in here, that I is not underneath the square root there, so it should not be underneath the square root in my next step. And then we'll come to the inside here, positive root 15I times root 3. Again, we can multiply the root 15 times the root 3, and that'll be a positive root 45I. And then we have positive root 15I times negative root 15I. So that's going to be negative. And then root 15 times root 15 is root 225. And then I times I is I squared. All right, let's simplify. We know the square root of 9 is 3. We know negative root 45I plus root 45I are opposites, so those add up to 0. And then we have minus the square root of 225 is 15. And then we also know that I squared is -1. So if we simplify that, we get 3 plus 15, which is 18. And we knew from the beginning, because these were complex conjugates, because they were just opposites of each other, there should not be any imaginary number in my answer, and there's not. So I'm just going to make a little note here, because we started with complex conjugates, and I'm going to abbreviate there. So there's no I in our answer.